Dear students, in our last lecture we have completed the concept, the derivatives of a composite function, in which we have solved some examples related to the exercise 3.1. Now today we are going to discuss another concept, that is derivatives of an inverse functions. So let us see. Now inverse function or inverse of any function exists if the given function is 1 1 and on 2 on its domain. You must know what is the meaning of 1 1 function and on 2 function. Just as per your basic knowledge, here we are going to discuss only the derivatives of an inverse functions. Okay, so for that you remember only that inverse function exists if the given function is 1 1 and on 2 on its domain. Okay, now see, I will explain this by one example. Here it is. See here, if y is equal to f of x is equal to x square. See, y is equal to f of x is equal to x square is 1 1 and onto function in its domain. See, if the domain set is properly defined for this function to become a 1 1 and onto function, then suppose it is f of x is equal to x square, then the inverse function exists as per the definition. So what is the inverse of this function? How will you write? See, if it is y is equal to x square, means y is equal to f of x is equal to x square, then x means inverse function. See here, x is equal to f inverse y. See, if you compare this properly, then if it is y is equal to x square, then what is x? X is equal to root y. See, this is called as inverse of this function. Inverse of y is equal to f of x is equal to x square. So to get the derivatives of an inverse function, you just remember how to find out the inverse of a function. If it is y is equal to x square, then the inverse of that function is x is equal to root y. Okay. Now we will see the further concept. So there is a theorem given to you in your textbook. See here, if y is equal to f of x is differentiable function of x and inverse function x is equal to f inverse y exists. See here, y is equal to f of x is differentiable function of x, means what? Dy by dx exists, means derivative of y with respect to x exists. Differentiable function of x means dy by dx exists. And if the inverse function, see how will you write the inverse function? It is written as x is equal to f inverse y. See, compare this, y is equal to f of x, then what is x? X is equal to f inverse y exists. Then the theorem says that x is equal to f inverse y is also differentiable function of y. See, x is equal to f inverse y is also differentiable function of y, means derivative of x with respect to y exists. See the meaning of this statement perfectly. Derivative of x with respect to y exists such that, see here, how will you get dx by dy? Means derivative of x with respect to y, it is given as dx by dy is equal to 1 upon dy by dx. So you remember this as a rule to get the derivative of inverse function. Okay, where dy by dx is not equal to 0. Only the statement of the theorem is given in your textbook. So no need to prove this result. Directly we will apply that dx by dy is equal to 1 upon dy by dx, where dx by dy is the derivative of inverse function, means derivative of x with respect to y. And how will you get that? By taking 1 upon dy by dx, where dy by dx is the derivative of y with respect to x. Now let us see some more about this. So if you take the function y is equal to f of x is equal to x square and its inverse function is x is equal to f inverse y, that is equal to root y. Then what is the relation between the original function y is equal to f of x and its inverse, that is x is equal to f inverse y? Let us see. See here, if you take the composite function of that, means composition of f inverse and f, see how will you write it? It is written as f inverse composite f of x. It can be also written as f inverse of f of x. See, this is called as composite function. It is the composition of function f and f inverse. So f inverse composite f of x, that is equal to f inverse of f of x, that is equal to f inverse. What is f of x? F of x is x square. Now f inverse of x square, see, f inverse of y is root y. So f inverse of x square is root of x square, and root of x square is x. So in short, the composite function of f inverse and f inverse and f of x is equal to always x. So what is our conclusion? For any function, f inverse composite f of x is equal to x. See here proper, f inverse composite f of x means f inverse of f of x. Here f of x is x square, just put here value, that is x square. So f inverse of x square, how will you get f inverse of x square? See here, f inverse of y is root y. So f inverse of x square is root of x square, that is here x. So in short, what we get? F inverse composite f of x is equal to x for any function. Okay. Now if you consider that f inverse composite f of x is equal to x, now if you differentiate both sides with respect to x, now how will you differentiate this? See, d by dx of f inverse of f of x is equal to, now derivative of x is 1. See, here we differentiate LHS as well as RHS. So derivative of RHS is 1. So d by dx of f inverse of f of x is equal to 1. Now how will you get the derivative of f inverse of f of x? By chain rule. So if you apply the chain rule, then it will be f inverse dash, see, f inverse dash of f of x into f dash x, that is equal to 1. This is by chain rule. See, f inverse of f of x. So how will you get that? F inverse dash of f of x into f dash x. This is by chain rule. See here properly. Now next step. So that is f inverse dash of f of x is equal to, it will be 1 upon f dash x. See, transfer this term to the right hand side. So it will be 1 upon f dash x. So that is f inverse dash. What is f of x? F of x is y. So f inverse dash of y is equal to 1 upon f dash x. So we get the relation between the derivatives of the function and its inverse, that is f inverse dash of y means it is dx by dy. F inverse dash of y means dx by dy. So dx by dy is equal to 1 upon dy by dx. So this is one technique to get the relation between the function and its, means derivatives of the function and its inverse. So you just remember this rule while getting the derivative of inverse function. Okay. Now let us see one note. What is the meaning of dy by dx? Dy by dx means rate of change of y with respect to x. So if you try to find out the rate of change of y with respect to x, then mathematically it is dy by dx. Similarly, another meaning is dy by dx means marginal y with respect to x. Okay, so you just remember these two notes. Now we will solve the exercise 3.2. Some examples related to exercise 3.2. with this knowledge. Now see the question. Here is the question. Find the rate of change of demand X of a commodity with respect to price Y. See, you know the meaning of rate of change. Rate of change means derivative. So here we require rate of change of demand X of a commodity with respect to price Y. Demand depends on price. So demand and price are uh, interrelated concepts. Now take one example. See here, function is given y is equal to 10 plus 4x plus 3x square. Now what we require, we have to find out the rate of change of demand x with respect to price y. Means what? Rate of change of x with respect to y. Means we require dx by dy, remember. But here in this case we will get dy by dx first. Means if you differentiate this given function with respect to x, then first of all you will get dy by dx. But actually as per this question we require dx by dy. So see here. So we differentiate with respect to x. Then we get dy by dx. See, derivative of 10 is 0 plus derivative of 4x, 4 as it is, and derivative of x is 1. So we get 4 here plus this is 3x square, 3 as it is, and derivative of x square is 2x. So 3 into 2x is 6x. So after differentiating given function we get dy by dx, that is 4 plus 6x. But what we required, as per the question we required dx by dy. See the meaning of rate of change of x with respect to y. So we require dx by dy. So very simple, we know that. How will you get dx by dy? Dx by dy is equal to 1 upon dy by dx. So what is the answer? So dx by dy is equal to 1 upon 4 plus 6x. So remember, here the original function is given y is equal to 10 plus 4x plus 3x square. After differentiating we get dy by dx. But as per this question we require dx by dy. So how will you get dx by dy? Dx by dy is equal to 1 upon dy by dx. Hence it is dx by dy is equal to 1 upon 4 plus 6x. So this is the derivative of the inverse of the given function. Okay, given function is y is equal to 10 plus 4x plus 3x square, and the derivative of its inverse is 1 upon 4 plus 6x by the meaning of this rate of change of x with respect to y. Okay, so this is first example from your exercise. Now let us see another example. Suppose if it is y is equal to 14x plus log of 1 plus 3x is given to you. Now in answer, first of all we have to find out dy by dx. So differentiate with respect to x. So what will you get? So we get dy by dx. Now derivative of 14x. 14 as it is, derivative of x is 1. So it is just 14 plus derivative of log of 1 plus 3x. Now we know that derivative of log x is 1 upon x. Here it will be 1 upon 1 plus 3x into d by dx of 1 plus 3x. This is by chain rule. Okay. Now it will be dy by dx is equal to 14 plus, now what is the derivative of 1 plus 3x? Derivative of 1 is 0 plus derivative of 3x is 3. So you can write it as 3 upon 1 plus 3x. Okay, so derivative is completed. Just cross multiply this. So 14 into 1 plus 3x plus 3 upon 1 plus 3x, and after solving we get 14 plus 42x plus 3, means here we multiply by 14 upon 1 plus 3x, and hence we get dy by dx is equal to 17 plus 42x upon 1 plus 3x. So just by taking some steps we get this proper answer, that is of dy by dx. But we require dx by dy. we require dx by dy. So again we know that dx by dy is equal to 1 upon dy by dx. So that is dx by dy is equal to 1 upon 17 plus 42x upon 1 plus 3x, and hence the answer is 1 plus 3x. This is the reciprocal. So 1 plus 3x upon 17 plus 42x. Okay. So in this lecture what we have studied? We have studied the derivatives of an inverse function. So first of all we have discussed about the inverse function, means existence of the inverse function. Then what is the relation between the derivative of the original function and its inverse, that is dx by dy is equal to 1 upon dy by dx. And just by the meaning of the derivative, that is rate of change of y with respect to x, means dy by dx, we have solved two questions related to exercise 3.2. So let us try such type of questions. Okay, I hope you have understood this concept of derivatives of an inverse function. Okay, in next lecture we will study some more about this inverse function. Okay, so thank you.